Good afternoon, Block 2. Thank you for your work today in chemistry. I apologize that I can't be there. I'm actually recording this video from Bumrungrad Hospital, where my son is in the hospital with the flu. Quite a bad case. Temperature went up and lots of issues. But he's going to be okay and all is well. But my wife, of course, decided to get sick at the same time. Well, okay, it's not her decision. It's what happens when you're in a family. So I'm here at the hospital taking care of my son so that my wife can be at home taking care of herself. The timing is not all that great because I plan to go on Wednesday to Amsterdam for a 3-day IB conference. I will update you later on that. But I'm going to do my best to take care of you in my absence, and I will ask that you have some flexibility and maintain a strong work ethic, and we'll get through this, and also understand that I'll work to answer all of your questions. If I don't answer them when I'm gone, you can make sure that I answer them when I'm back so that I can be there to answer those questions. In terms of marking your assessment, this weekend was going to be my marking time, and then I ended up here at Bumrungrad pretty much the whole weekend. Friday I was able to do my service, but then Saturday and Sunday, here I am. So I'm going to be behind on my marking, and I apologize for that. But let's get on. Let's talk about what we're going to do today. I'm going to do a quick reminder about chemistry's core ideas, and we'll discuss some of your questions. I'll have some haiku resources and reminders at the end, and I'm going to handle this portion with a second video. That'll be kind of the same for Block 6 and Block 2 today, but this is just an introduction just for Block 2. Yes, we were scheduled for HL time today. I apologize, but I'm going to choose not to use HL time today since I'm not there. I think I'd rather just be there for HL time. I don't feel an urgent push to really need that 35 minutes today. I think I can make it work anyway. In terms of homework, you have 2 videos. It's possible you will finish today's classwork early, at which point you can start the homework. Yes, it's 2 videos, but they are shorter than normal. I would suggest that you ask questions in Edpuzzle just like normal, and I will do my best to make them work during class time with some videos like this. And if I can't answer questions because of the timing of everything and my flights and all that, then just trust that I'll answer questions when I get back. So please try and take care of those videos, and they both are a little bit shorter than normal. Okay. I want to do a quick refresher on chemistry's core ideas, and I don't need to do much more than just offer you a couple reminders. Now that we're talking about chemical bonding, we really should revisit idea number 3, which is that bonds form between atoms by sharing electron pairs. So we don't have to go through the entire wording of main idea number 3 today. I'm really interested in giving you a refresher just to make some connections. Chemical bonding, as we're learning, is the sharing of electrons. Now, what about ionic bonding? Well, Dr. Atkins would suggest that ionic bonding is just an extreme version of sharing, where really the electrons are shared in one direction only. But sharing electrons, and here, remembering that the number 2 is really important in chemistry as well. 2 electrons in each orbital, maximum for an atom. 2 electrons per covalently bonded pair. A single bond is 2 electrons. A double bond is 4 electrons. So there are lots of relevance. There is a lot of relevance to some of the other things that we've discussed as well. Main idea number 4. Shape is of the utmost importance. We are starting to learn about shape. And I'm not there today to show you physical models, but I would suggest in working through the video that I'm going to take you through, the second video, that what you might call content, that you actually take the time to build the models. I will suggest that building the models will help you see the shapes better than a screen, something on the screen. I think comparing both would be really helpful. So I definitely suggest taking the time to build the models. And I'll probably say it in the second video. You might hear it from me more than once. Sorry if I sound like a broken record, but shape is incredibly important, and it will relate to main idea number 5. excuse me. It will relate to main idea number 5 as well, which is about how molecules interact. So there's a lot going on here with chemistry's main ideas. Now I want to relate to your questions. So block 2, you asked a few questions. One question that you sent to me was, what do you mean by the word species used in a sentence? Lewis dot structures show the electron domains in a covalently bonded species. So the word species here really means molecule or compound, and I'm sorry about any confusion that word creates for you. Why does repulsion lead to a change in shape? And in the second video, we will spend a great deal of time talking about how electron pairs and repulsion leads to a change in shape. So I'm not going to answer that one here in this video, but I'm letting you know that I've seen the question, and I will be discussing it in the next video. And then I had one student request the Lewis structure for NO2-, the nitrite ion, and double bonds. Will we be given a handout with all of the relationships? And so this question I will be discussing later in the second video, but the second question, will we be given a handout or sheet with all of the relationships? The answer to that is yes. And I discuss it down here. And the reality is it's later though, because there's more information coming, most specifically hybridization. And that will tie things together a little bit. And so giving you a sheet now would be a bit premature, but you do have sort of the first handout. And that's that VSEPR handout that I gave you that has 13 molecules. That's the first place to start. And in the second video, we'll be starting to kind of put these relationships together into a pattern. So that's my sort of intro slides for block 2. When you're done with this, please spend a minute or two maybe getting yourself organized. Have your molecule building activity handout in front of you. Have the VSEPR handout, which was 1 page front and back. Have that handout in front of you. And have a model kit on your table so that you can build some molecules. And then head to the next video. And there you go. Thank you. Again, I'm sorry I'm not there to help you, but I appreciate your work, and when I get back, we'll make sure that I take time to answer any questions that are needed. Thank you.